In this demo, I will show the main new features introduced in the Cisco Next Generation Firewall 9.2.1 release. We'll start off by looking at the Prime Security Manager Network Overview dashboard, which gives us a quick overview of the status of the devices we are managing, as well as an overview of what's going on our network. Prism can not only manage your Next Generation Firewall, but also classic ASA features. Here we are managing an active standby failover pair of 5585 firewalls with Next Generation Firewall modules. The failover pair appears as a single device in Prism for configuration and reporting. As you can see, Prime Security Manager is also managing a standalone ASA 5585 with Next Generation Firewall module. We'll be using this firewall for our demo today. Now let's have a look at licensing. The licensing page shows what feature licenses are available and to which devices licenses have been applied. You can also upload new license files and apply them to a device directly from this page. Trial feature licenses are available by default, but not yet applied to the devices. Let's apply an IPS feature license to our ASA4 firewall. After applying the license or making any configuration change, we need to commit and deploy the change. This page shows us the changes that are pending. Now that we have an IPS license, we can go ahead and configure some of the key features. The Policies and Settings page is where you will be doing most of your configuration. In the menu on the left, you can choose between Device View and Repository View. On the screen, you can see that Prime Security Manager is managing two logical devices, which really are one standalone ASA and one active standby failover pair. Configuration elements in the device view include things like traffic redirection, which is telling the ASA what traffic to forward to the Next Generation Firewall module, intrusion prevention, which we'll look at in detail today, and also access and decryption policies. Let's open up our access policies. There are three types of access policies: inbound and outbound firewall access control lists, and context-aware policies which apply to Next Generation Firewall services. Access policies can be assigned universally to all devices, shared amongst a couple of devices, or applied to only a specific firewall. Here we have a context-aware access policy matching peer-to-peer traffic for a specific group of users. Looking at the details, we can see that this policy is matching any user except for the IT staff. Furthermore, when looking under Profiles, we see that we apply rate limiting to the traffic, and we are matching peer-to-peer applications including BitTorrent and Filetopia. Note that rate limiting applies to the aggregate of traffic matching the rule and not to just one flow. Let's check out the IPS configuration. IPS is turned off by default and can be turned on once an IPS license has been applied. Just turning the IPS toggle from off to on will apply a default IPS protection level to the device. You can customize the IPS protection by creating a new IPS profile. The IPS can take three different actions when a threat is detected: block and monitor, allow and monitor, or allow and don't monitor. This slider bar allows us to define which action the IPS will take when a threat with a certain threat score is detected. A threat score indicates what the potential risk is of each individual threat. We can override this behavior and tell the IPS to always take a specific action for a certain threat, regardless of the threat score, by configuring an exception. Let's create an override here for a vulnerability we will be exploiting in a couple of minutes. To prove that the exploit actually works, let's tell the IPS to just alert us and not block the exploit. Once we have configured the basic settings and exceptions, we have 3 more advanced settings to look at. If Scan High Reputation Traffic is turned off, the IPS will not inspect web traffic to and from websites with a high reputation score in order to minimize the performance impact. Only web traffic to and from websites that have a low reputation score will be scanned in this mode. This is the default setting. By default, Block Blacklisted Traffic is enabled. This means that any traffic to and from an IP address or subnet on the blacklist will be dropped even if it doesn't match any IPS signature. Eventing, it determines whether we will generate an alert when traffic is dropped because of a blacklist match. Now let's create another IPS profile. We can create any object, including IPS profiles, from the Components Objects page. Let's call this one IT Staff IPS Profile and configure it to take the Allow and Monitor action for all the risk ratings. We'll apply this to our IT staff and allow them to run vulnerability tests without the IPS blocking the tests. Let's go back to our access policies. We'll add a policy on ASA4, which is matching our IT staff user object, and matching the DMZ interface role, which is matching all of our DMZ interfaces. Now I'm removing the device level IPS profile, which is applied by default, and replacing it with the profile we just created. As you can see, the Internet Edge profile was applied to the device level, which means it will apply to any access policy unless we explicitly change that in the access policy. Let's confirm this in one of our access policies. Here we go. The Internet Edge device level profile was applied to this access policy. We could select a different profile or simply remove it if we don't want IPS inspection for the traffic matching this access policy. Let's not forget to deploy the changes. And here we see all the changes since our previous deployment. We finished our configuration, so now we can have a look at some events. The event viewer has different tabs for the different next generation firewall components. We can look at an aggregate of all events, or we can look at something specific, such as context-aware security events or IPS events. The event viewer allows the user to look at real-time events or historic events. We can filter on any of the event parameters, such as the name of the threat. We can look at the details, but most of the relevant information about an IPS event, such as the attacker, target, and threat, is displayed right here. Let's change this to real-time eventing and demonstrate a live attack. Now we are looking at our attacker who's using Metasploit to host a client-side attack over HTTP. And here's our target. Our domain user Ira is logging on to his Windows 7 host and he's looking at his email. Unfortunately, he doesn't hesitate to click a link. Without Ira knowing this, an HTTP session is established to the attacker's Metasploit web server and exploit code is being transferred. Back on the attacker's console, we see the session that came in from the victim and we can use the reverse shell that was established to interact with the victim's machine by, for example, opening a Windows command line. Let's see if our IPS detected the exploit. You can see here that we have an informational IPS event, informing us that we detected a threat, but we did not drop it. Let's have a look at the details. We see our user Ira Blue was both the source of the traffic, as he initiated the client-side HTTP request, as well as the target of the attack. That's typical for a client-side attack. We also see other relevant information, including a slightly negative web reputation score. Expanding the policies section here shows the policies that triggered this event, including the device-level IPS profile. Remember that we configured an exception in our device-level profile to allow this threat. Let me remove that exception from the IPS profile to verify the IPS will block the threat. We can filter on all IPS profiles. Now we select the Internet Edge IPS profile, edit and remove the exception. Now we'll save and deploy. Now let's go back to our target and try to reinitialize the client-side attack. Back on the attacker, we see that this time we are not getting a reverse shell, which indicates that something blocked the attack. And now when we look at the event viewer, instead of an informational event, we get a deny event, again including all the relevant contextual information. In the final part of this demo, we'll investigate how the IPS and HTTPS decryption next-generation firewall components complement each other. Looking at the decryption settings, you can see that we have installed a certificate on our next-generation firewall and enabled the decryption feature. Besides enabling decryption, we also need to configure a decryption policy to tell the next-generation firewall which traffic should be decrypted. For the purpose of this demo, we've made it simple and we've chosen to decrypt all the traffic. Now we'll look at another attack. Our attacker has gone smarter and is actually hosting his exploit code on a website he hijacked. The website is using HTTPS, which the attacker makes use of in an attempt to evade detection. Our victim Ira got a second email. This time the link is a secure link, which leads Ira to believe this must be safe. He clicks the link, but the web page does not display. Let's investigate what happened using the event viewer. As you can see, we are looking at the Encrypted Traffic View tab in the event viewer, which shows events related to encrypted traffic. We see an event sourced from Ira Blue. Let's have a quick look at the details. Here we can see the certificate from our server, and we can also see that we've decrypted the flow. We can now select one of the relevant parameters, such as the server certificate, to create a filter. These filters remain in place when we move to different event tabs, so now we can easily find the related IPS events. When we look at the details here, we can see all the information that we need to investigate what happened. Information about the source, in this case ArrowBlue, information about decryption, and more information about the destination, which, as you can see, is a website with a good reputation. We can expect that the reputation will be lowered if this website keeps hosting the exploit code. We can also see information about the application that was detected, and of course information related to the threat. Finally, we get confirmation that the attack was blocked. And that's the end of our demo.